Today we're going to take a deep dive into Wi-Fi 7 and hopefully explain to you how insane it can be speeds wise, but then also some of the problems that can crop up whilst you're using Wi-Fi 7, so you know what they are when you come across them, because you will come across them. Welcome to this deep dive into Wi-Fi 7. So first, let's talk about wireless bands and set the baseline. You've got 2.4, 5 and 6 gigahertz, which means tri-band, 3 different bands. The term Wi-Fi 7 just means the generational leap within Wi-Fi technology. What people don't really talk about is the frequency, the 2.4, the 5 and the 6 gigahertz, and the differences between these frequencies and what you can actually expect. If you understand these frequencies, you'll be able to troubleshoot any Wi-Fi problem that comes up within your life. I absolutely guarantee that. You can get dual band Wi-Fi 7 routers and access points, which will just come with the 2.4 and 5 gigahertz, leaving off the 6 gigahertz. But the 6 gigahertz is where all the fun really happens. But that's still absolutely fine, because as I've mentioned, Wi-Fi 7 as a standard brings upgrades to all 3 of the bands, even our slow, measly 2.4 gigahertz, and even brings tech like MLO, multi-link operation, to merge all of these bands together for faster than gigabit speeds. But hold your horses, we're not there yet. So far, Wi-Fi 7 routers and access points have been quite expensive whilst this new technology has been in its infancy, but in recent months it's come down in price quite a significant margin. This is the RTBE92U, and it's a really cost-effective, full-on tri-band Wi-Fi 7 router, and it can also be set up as a repeater, a standalone Wi-Fi access point, or it's got the ability to use AI mesh. This device here is less than £250 here in the UK, has all 3 bands and Wi-Fi 7, and it's what I've been using to explore the latest generation over the last week. Okay, so let's set up some wireless networks to do our tests. I'm in the admin panel here of the BE92U, and as mentioned, Wi-Fi 7 affects all 3 of the bands, the 2.4, 5 and 6 gigahertz. So let's start with the slowest, the 2.4G. Although the 2.4 is the slowest, it will provide the best range. So I'm going to select 2.4 gigahertz only here, give this a name and a password, and then we can click save. Now, if you're to take out a device and scan for Wi-Fi, you should see this wireless network that we've just created. Not you, here in the studio. After running some speed tests on the 2.4 gigahertz network using an iPhone 15 using Wi-Fi 6 and an iPhone 16 using Wi-Fi 7, you can see that there's a fairly decent increase in the speeds here. It looks as if there's around a 32% increase on 2.4 gigahertz, talking about raw speed on Wi-Fi 6 versus Wi-Fi 7, which has basically put 2.4 gigahertz in a strange position, because previously I would have said don't really use the 2.4 gigahertz band at all unless you have to, yeah, you might actually now be able to use the 2.4 gigahertz band for more demanding devices like smart TVs streaming 4K video, for example. On the whole though, I'd still generally stay away from the 2.4 gigahertz band if you can, and reserve this band for things like smart devices, thermostats and Alexas, things of that sort of nature. It's just generally a slower band compared to the other 2. So next, let's look at the 5 gigahertz band, the most popular band I would say, and for good reason. Reason 1, because it can deliver some really fast speeds, and reason 2, most client devices like phones, laptops, tablets and TVs actually support 5 gigahertz. So setting up our 5 gigahertz only band here, I'm going to make sure we've got 5 gigahertz checked, and I'm going to give this a different name than our 2.4 gigahertz band, and then I'm going to click save. The reason we're going to give this a separate name than the 2.4 is so that when we're choosing the Wi-Fi network on our phone, we 100% know that we're connected to the 5 gigahertz. On the graphs, it doesn't look like a massive increase in speed, but you have to remember that 5 gigahertz Wi-Fi on Wi-Fi 6 was already blazing fast, so we'll take anything as an upgrade here. I'm not going to go and throw loads of terminology at you that you won't understand about how Wi-Fi 7 is better than Wi-Fi 6 on the 5 GHz frequency band. All you really need to know is it can handle more data and the highway can be bigger, meaning more data can fit on the highway, meaning more speed, in a really simple term. Achieving way over gigabit speeds over Wi-Fi is absolutely astonishing to me. 1.6 gig on Wi-Fi 7 at 6 GHz is crazy sauce. If you look at the 6 GHz band on Wi-Fi 6E versus Wi-Fi 7, again we can see a slight increase in throughput up on our Wi-Fi 7. However, it doesn't look like that much of an improvement on the graphs because the 6 GHz speeds at Wi-Fi 6E are still blazing fast. However, you can expect about a 200 meg jump from Wi-Fi 6E to 7 on 6 GHz, which is a lot of throughput. The problem is most people complain about their Wi-Fi because they're probably using the 2.4 GHz band without even knowing that they are. Even though we've seen improvements with Wi-Fi 7 on 2.4 GHz, you will still have a far better Wi-Fi experience using the less crowded and faster 5 GHz and 6 GHz bands. The only annoying thing is to be able to choose what band you're using, you have to separate the names like we've been doing in this video within the router itself, which when you scan for Wi-Fi gives you a complex mess of different networks to choose from and can be quite confusing. So is there anything else with Wi-Fi 7 to get excited about other than the speed increases that we've noted across all 3 of the bands? The answer's something big, and it's called MLO, or multi-link operation. So you know how we've been testing the 3 bands individually, and to do so I've been giving each band its own separate Wi-Fi name. Well, MLO sets out to solve this issue by giving you just one wireless name with all 3 of the bands, but it doesn't stop there. Imagine taking the speed test that we got on 2.4, 5 and 6 GHz and aggregating those speeds together, and that number then being the amount of bandwidth that you have to play with. But there's a catch. You see, I purchased the latest iPhone 16 Pro to make this video and test Wi-Fi 7. Despite on Apple's website it claiming that the iPhone 16 supports Wi-Fi 7, which it does, and it supports MLO, for some reason I can't seem to get the speeds to aggregate together. I'm hoping this is something that Apple can fix within a software update. It doesn't mean it's all bad though. Even though the iPhone 16 with its Wi-Fi 7 and MLO doesn't aggregate the speeds together, it does a far better job of deciding what network to put you on, seeing as all of the wireless networks, the 2.4, 5 and 6, are being broadcast with the same Wi-Fi name. Now, I know what you may be thinking. You may as well just give all 3 of the bands, the 2.4, 5 and 6, the same SSID or network name and then just call it a day. And no, you'd be wrong. And this is where most of the networking or Wi-Fi issues that I come across spawn from. If you do it this way, your device will most probably just connect to the first Wi-Fi network it sees. And typically this will be the longest range 2.4 GHz signal, even if you are in range of the superior 5 and 6 GHz signals. With MLO enabled, the iPhone 16 does a far better job of choosing what band it actually uses. So, in other terms, if it's in range of the 6 GHz band, it will most likely put you on that 6 GHz band. And it makes handing off from the 6 GHz to the 5 and even to the 2.4 that little bit more seamless. So you get less drop packets as you're roaming around, which is really neat technology. The main thing people don't realize is both the client device and your router or access point have to support Wi-Fi 7 for these features to actually work. And you're probably thinking most of the devices in your life, the same with me as well, don't actually support Wi-Fi 7. For example, my 2021 MacBook M1 only supports Wi-Fi 6 and therefore can't take advantage of these new features. But if you look at it from a broader spectrum, it actually can. Having that extra 6 gigahertz band opens up loads of extra highway to distribute the traffic over 3 bands instead of 2, leading to an overall better experience on your Wi-Fi network. So even though some devices that you may have, possibly all of them, don't support Wi-Fi 7, having the extra highway will make your Wi-Fi life easier. The RTBE92U, which we've been using over the last week for our Wi-Fi 7 test, can be had around £250 currently, which in my opinion really isn't a lot considering the price of these new tri-band Wi-Fi 7 routers. And you have to remember, we've just been testing this thing's Wi-Fi performance as an access point. This is a full-on router with AI mesh capabilities, a 10G and a 2.5G LAN port on the back. So I'll put the links to all that in the description if you want to check it out. But this has been our deep dive into Wi-Fi 7 as of late 2024. I'm looking forward to 2025 where loads of devices are going to be coming out that support Wi-Fi 7 and the MLO aggregation. Anyway guys, my name's been Alex, this has been TechFlow, and I'll see you in the next one. Peace.